Hello everyone and welcome back to the channel. In the world of microservices, we aim for small independent services. But what happens when each of these services needs common functionalities like logging, monitoring, or security without bloating the service itself? Copy pasting code everywhere is quite messy. This is where the sidecar patterns come in, which is an elegant solution that decouples cross-cutting concerns from your main application logic. In systems and interviews, discussing the sidecar patterns demonstrate a sophisticated understanding of microservice architecture. Today, we are diving into what it is and why it's so powerful and how it works. So, let's try to understand the problem first. In microservice architecture, every service needs to handle common non functional requirements. Imagine each of your 50 microservices, for example, need to send logs to centralized log system, collect metrics for monitoring dashboards, implement security features like MTLS or mutual TLS or authentication token refresh. Also, it needs to handle network configurations and service discovery. So, if you bake this code directly into each microservice, you will have a lot of problems. One of them, it will be like you are duplicating code across many services. Also, it creates tight coupling between your core business logic and infrastructure concern. Also, you update a common library requires also whenever you update a common library, this will requires rebuilding and redeploying each service that using this library. It introduced a technology lock-in because all services must use the same language framework for these specific tasks. So there is a lot of problems. The sidecar patterns help in solve this problem. Basically, the sidecar patterns involves deploying a secondary container alongside your main application container within the same pod in Kubernetes or host. This is sidecar container encapsulate a set of common functionalities that are tightly coupled to the primary application's lifecycle but remain decoupled from its core business logic. Okay, so how it works? First, we have shared environment. The shared environment, basically both your main application container and the sidecar container are deployed together in a single deployment unit in Kubernetes pod. Okay, they share network namespace, like they can communicate with each other via localhost. This is crucial for their interaction. Also, we have volumes. Basically, it's optional but common. They can share disk volumes, allowing to the sidecar to read and write files that the main application produce or consume. In terms of the life cycle, I would say they typically start and stop together. If the pod is killed, both containers within this pod are terminated. So next thing we want to talk about, which is the encapsulation of cross-cutting concerns. Like the sidecar container runs the code for a specific non-functional requirements. For example, a logging sidecar like might capture all logs emitted by the main application and stream them to a centralized logging. We can add like a monitoring sidecar, like could scrap metrics from the main application's endpoint and push them to a monitoring system. We could have like a service mesh proxy sidecar, which will handles all inbound and outbound network traffic for the main application, performing service discovery, load balancing, MTLs, tracing, and circuit breaking. Also, lastly, communication, which is the main application will communicate with the sidecar usually via a local host because both of them are in the same pod. Okay, so this design cleanly separates concerns, allowing each container to be updated, deployed, and managed independently within the same deployment unit. Okay, why the sidecar pattern matters in system design? There are several reasons. We will talk about seven of them today. The first thing is decoupling concerns. Like it cleanly separates infrastructure concerns like logging, monitoring, security, networking from your core business logic. Your microservice can focus on what it does while the sidecar handles how it integrates within the platform. Number two, simplified development. I would say developers of individual microservices don't need to write or maintain complex boilerplate code for a cross-cutting functionalities. They just configure their service to talk to the local host or the local sidecar, and that's it. Number three, technology and the heterogeneity. You can I always pronounce this word wrong. Always, always. Let me give me a minute here to make sure that I'm pronouncing it in the right way. Uh-huh. Heterogeneity, not heterogeneity. Heterogeneity. Okay, so technology heterogeneity. Here, I would say you can use different languages for frameworks or for your sidecar than your main application. For example, like you can use like Java for microservice and use Rust based for logging sidecar, things like that. And number four, we have independent upgrades and patching. Like you can upgrade or patch common sidecar component without needing to rebuild and redeploy every single microservice. Number five, improved observability. Sidecars can centralize metric collection, logging, and distributed tracing from the application container. Number six, enhanced security. A sidecar can enforce security policies like MTLs at the network edge of the application without the application itself needing to handle complex crypto. Number seven, which is lastly resource optimization. While adds another container, sidecars can sometimes be more efficient than running duplicate code within every service, or they enable features that would be complex otherwise. Okay, so there are some challenges and considerations and systems and reviews when we talk about Sidecar. First, we have increased in resource consumption when it comes to Sidecar because each pod now has multiple containers consuming more CPU and memory per deployment unit. Number two, we have increased complexity. While simplifying the individual microservices, the overall architecture becomes more complex with more containers and their interactions. Number three, we have shared lifecycle. The sidecar shares the main application's lifecycle. If the application crashes, the sidecar might be affected, and vice versa. And lastly, I would say debugging. Debugging issues between co-located containers can sometimes be quite trickier than monolithic debugging. So yeah, that's it for this video, and see you in the future.